And what z-scores are, they tell you how a certain person varies from the center. So if they have a positive z-score, they are above the average. If they have a negative z-score, they are below the average. We use this quite a bit in stats. I hope you enjoy finding them, and I hope you use your own data, to be honest, something you're interested in. So let's get going. You will need your stats disk again, and we will be doing some things by hand. We're going to compute a z-score and what it means. We're going to look at percentiles and quartiles. This is so we can create our 5-number summary or a box plot. Now, a z-score is the number of standard deviations that a value is above or below the mean. So it can be positive or negative. To find it, you take the value that you're looking for minus the mean, and you divide it by the standard deviation. It's not too difficult to calculate. You will have to do them by hand, though. Okay, the number of standard deviations that a given value is above or below, we already talked about. There are no units. You're either 2.5 or negative 5.8. It's not seconds or anything like that. It's just what your z-score is. Okay, it's significant if it's below or above by 2 standard deviations. If it's in 2 standard deviations, it's not as significantly high or low. And it's less than the mean, it corresponds to a z-score is negative, which we've talked about already. So let's move on. I want to calculate the z-score of a weight of a newborn baby that weighs 8.8 pounds. This is its weight, so this is Rx. Oh, I should have had a capital I there. Now, if the sample mean is 6.9 and the standard deviation is 1.5, so we take the 8.8 pounds, we subtract the mean, which is a 6.9, and we divide it by our standard deviation of 1.5. Okay, when you do that, type that in your calculator, you should get 1.27. It's positive, so this is the z-score, and this baby is 1.27 standard deviations above the mean. So this means it's a fairly large baby. Is it significantly high or low? The answer is no, it's not over 2 standard deviations or below 2 standard deviations. Okay, pause and do yours. Okay, I hope you found out this person's in trouble. You took his platelet count, you subtracted the average platelet count, you divided by the standard deviation, and you got a negative 2.56 z-score. This means this person's blood count, or platelet count, is below 2 standard deviations from the mean, so there is something wrong. Something needs to be checked. Percentiles. Now we're on to box plots. All right, so remember those box plots with our box and whiskers, sometimes they were called when you were littler? All right, we do this with percentiles, and a percentile just means there's 100 of them in a group. So we're breaking everything down into a percentage. And I want to know what percentile you fall in. So when you read some of your data that you get back when you take standardized tests, they're usually in percentiles. So if that says you are in the 60th percentile, that means roughly 60 people are below you and 40 people are above you, is what that means. It's a rough estimate. So now we need to calculate this. So we have to take the percentiles, the number of values less than X, total number of values times 100. So let's look at our data values here. We have the Verizon cell phone data. It's already in order for us. And let's send the range and increasing or find the percentile for the data speed at 11.8. I want to know where this guy falls. So the first thing we do is we go to our data and we find 11.8, which is here. All right, next step, how many data items are below 11.8? So you count them and you should have gotten 20. How many total data items do we have? We have 50. So 11.8 is what percentile of my data? So we take 20 divided by 50, which gives us 0.4. So you multiply it by 100. So we get the 40th percentile is what we get here. I should not have written it that. It's just called 40th percentile, not 40th percent. My fault. All right. So that means I have 40% of the data below me and roughly 60% of the data above me. Now, I want you to do the same thing for the speed of 18.2. So pause and give that. Okay, when you counted, you had 34 above out of your total of 50, which puts you in the 68th percentile. So 18.2 is in the 68th percentile of my data. So I have 68% below me and roughly 32% above me. All right, just a quick little diagram to help us get there. First, you have to sort the data. You calculate K divided by 100 times N, tells you where you're at, number of values, percentile in question. Is it a whole number? The answer is yes. Then you have to add the two and divide. The answer is no, you round to the largest next whole number, and this will tell us where we're at. So we're trying to find a percentile to a data value. I want to find the 40th percentile. So I take 40, okay, divided by 100 because I'm changing it back to a decimal, and I have 50 data items. So this is the percentile I want to find. 50 is the number I have, and it's the 20th data item. Well, 20th is even. So since I can't round up to get to it, I find the 20th and the 21st. So I look for the 20th and the 21st, which is 11.6 is the 20th and 11.8. So this is the 20th data value. This is the 21st data value. You add those up and divide by 2. So 11.7 is the 40th percentile. It's not in our data bank, but that's what it is. So I have 40% above me and 60% are below me and 60% above me. I can't find there it goes. Right here, I forgot to mention, if it's a whole number, all we do is, or not a whole number, we round up. So if this here had been, if I had found a different one, let's say, and it had turned out to be 12 point anything, say 2, I would round up to the 13th value, data value. I don't have to add. So let's go do this so we can start making these box and whiskers. Okay, in a box and whisker, you have your, right here, you have a whisker, which is 25% of your data. So your first box, or your quarter one, falls at 25%. Now, your inner quartile, you have a box here, 25% of your data falls here, and this in here is called quartile 2. So he is at 50% of your data. The next 25% falls here, which is quartile 3, so that's 75% of your data. And the last 25% of your data is the last whisker, as it used to be called. So we need to calculate all these things. The interquartile range is always Q3 minus Q1. A semi-interquartile range, so the average, is the Q3 minus Q1 divided by 2. Mid-quartile range is you add them divided by 2. I don't want to find the center. And the quartile range between 10 and 90, you just take the P90 minus P10. It doesn't really matter. All right, here we go. I have to create a 5-number summary or a box plot. These are the 5 data values I need. So the first thing we need to find is the min. I've already got them in order for us. So the min is the smallest number on our chart, or the 0.8. Next easiest one to find is the max, or the largest number. So that's the 77.8. Now we have to calculate our quartiles. All right, I have 50 data items. So this is how many I have. I want the 25th percentile because I'm in quarter 1. That's 12.5. Since this is a decimal, we just round up to 13th. And we find the 13th number, so we count over. And this is the 13th number, so 7.9 is Q1. Q2 is the median. I don't usually do it this way. I take the 50 times the 0.5, and that's going to give us, let's see if I calculated it out here, the 25th number. Okay, since that's the 25th number, I have to take the 25th number plus the 26th number and divide it by 2 to get my number. So that's 13.7 and 14.1. So this is the 25th, this is the 26th, add and divided by 2. So 13.9 is my quartile 2. Quartile 3, we take 50 times 0.75, so stop and do that. I'm hoping you got 37.5. It is not a whole number, so we just round it up and we find our 38th digit, which is 21.5. Now I have the 5 numbers I need to construct my box plot. All right, when you do this, I just drew this out and I probably shouldn't have. To start, you actually draw a number line, okay? And I have to get from 0 to 77.8. So I would do this one by tens. I would go 0, then 10, 20, 30, 40. Make sure they're even. Because your quartile has to be put on a number line. 0.8 is my smallest, so it would go here. 77.8 would go here. So I draw it above my number line. Now we have to put in our quartiles. Our quartile is 7.9, which is roughly here. So this is 7.9, 13.9, which would be roughly here, 21.5, which is here. And we construct our box. Then all we do is we draw the lines from the box to the whiskers. All right, if we look here, this is 50, and this one here is way more spread out this direction, so this one here is right skewed. The other thing to look at is your actual box itself. These here are very even, so there's not a lot to tell, but many times like a box may look like this. All right, and if that's true, this is saying that inside the box, inside your inner quartile, you have a larger range from the 50 to 75 quartile than you do from the 25 to the 50th quartile, just so you're aware that that can happen. All right, next, modified box plot. Now, we've talked about outliers before, but we haven't really done it, and this is where this comes into play. You take your inner quartile range, so which is Q3 minus Q1. All right, you take that number, whatever this number is, times 1.5. Okay, so this is where we find our outliers. Now we take the inner, or the 1.5, and we take our Q2 and we add 1.5 to it, and we subtract 1.5, this distance, whatever this number is, from it, and see if there's any data values above or below that, and those are our outliers. So let's go down here. We have 7.9, 13.9, and 21.5. Step 1, we take the 21.5 minus 7.9. Okay, we have our interquartile range. So now we take 13.6 times 1.5. This is always 1.5. And we get 20.4. So if anything is 20.4 away from our quarter 2, then we get rid of it or we add it. Okay, I think I said that wrong. If we are 20.4 above our interquartile range or below our interquartile range. So the Q1 and the Q3. So we take 7.9, our lower one, we subtract 20.4. Is anything below negative 12.5? Well, all of our data values are positive, so we have nothing that is lower. Okay, now let's check higher. So we're going to take the 21.5, so this is Q3. We're going to add the 24 and we get 41.9. If anything is above 41.9, then it is an outlier. So when we look at this, we've got 43, 55.6, 71.3, and 77.8 are all above our modified data blocks. So these are our outliers. They do not fit our mode. So something's wrong with them, or we've done something wrong in our data collection. All right, this box plot is still right skewed, but this is where our data should fall. All right, I hope you did well with that. Now, it's your turn. All right, I hope you kind of got stuck on this one. When you look at this, quartile 1, so we had 54 data items, 25% was at the 14th position, which was 0. Quartile 2, so 54 times 50 was 27, but when you had the 27th and the 28th spot, they were both 0. So again, you got 0. Your low number was also 0. Your high number was 200. Quartile 3 finally was different. So you got 40.5, which is your 41st number, which was 20. So your interquartile range is 20 minus 0, which is 20, times 1.5, which is 30, which is what we'll use for our modified. So to start with, you have 0 here 3 times. So this 0 represents the low, it represents quartile 1, and quartile 2. So this thing is right skewed, heavily. Correct? It is not a normal plot. This here is 25% of your data at all. So right here, you have 50% of your data all on 0. We went to 20, and then we go all the way out to 200 for our high. Now our modified box plot also starts at the 0. It goes to the 20, but when I add 30 to 20, we go out to 50, which means all of these here are outliers. So when you look at them, 54, 56.7, 97, 111, 120, 150, and 200 are outliers in our box. All right, I hope you did a good job. Good luck on your homework. I know I needed to give you more spice here. I'll have to work on that for next year. And get that done, and then tomorrow we will start our project. I do not want this done in 3 to 4 people. We will be doing this with 2 people. All right, good luck.